diagram below, the graphs of f of x is equal to the square root of k times x and g of x is equal to log base a argument x are given. The graphs of f and g intersect at point B with coordinates 3 and 1. There we go. F is blue, B encircled over there with those coordinates at that point of intersection. So determine the values of x for which, and listen to my reading of this, f is above g. That's all it's asking. If this is algebraically, it says f of x greater than g of x. We need to turn that into some sort of visual. Where is f more than g? And because these are y values, now remember, go back to grade 10 when we taught y is f of x or y is g of x, with f and g just being labels. It's easy to see that the area they are referring to is here, because from a vertical perspective, that is where f is greater than g. F is above g, which means what? We just have to track the values of x for which this statement is true, and those values are obviously right there and right there. So the x values here at the origin is 0, that's the one boundary, and the x value at B is 3, which is the other boundary, and x can be any value between those two, and then the statement becomes true. Now, determine the values of k and a. So, to do that, well, for f of x, because k exists over there, we're going to say that y is equal to the square root of k times a, and then we'll sub point P, 3 and 1 in there. 1 is then equal to the square root of k times 3. We square both sides and we'll get, well, 1 squared is still 1, and then we'll have 3k. Therefore, k is equal to 1 over 3. That sorts out that. And then for g of x, we'll have that y is equal to log base a of x. We'll sub in again b, having coordinates 3 and 1. Gives us 1 is equal to log base of a times 3. Now remember, the answer to a log is an exponent, so our exponent is 1. Our base remains, the base is 3, and that gives a is equal to 3. Now determine the inverse of f in the form y is equal to, and state its domain. So what we'll do is, for the inverse of f, we'll obviously have that x is equal to the square root of, well, k is 1 over 3, because we've got its value, and then this becomes y. So now we can square both sides, change up the color, so we'll have that x squared is equal to 1 over 3 times y. Moving on to our next step, we'll have that y multiply both sides by 3, because that's what we want to do. We'll have that y is equal to 3x squared. Now, how do we state its domain? Well, we have to look at the range of the original function, and we can see that it exists above the x-axis from the point 0, of course. Now, if that is the range, then of course the domain now takes that, so it means that x is greater than or equal to 0, and x is a member of the real values. So that answers that question.